Okay, today we're going to learn about geometric probability. This is section 11.7 in your chapter, and tomorrow you will have a review day, and the day after that you will have a test on all 7 sections in this chapter. The definition of probability is the likelihood that an event will occur. So this is the likelihood of an event occurring. And here's a spectrum of probabilities. If something is not going to happen and is impossible, the probability of that event would be 0. If something was certainly, absolutely, positively going to happen, the probability of that event would be 1. And then you have an unlikely probability would be 25 hundredths. Equally likely of an event would be 50 hundredths. And more than likely something happening would be 75 hundredths. So probability of an event would be written this way, and the values would fall in between and including 0 and 1. So the probability value should give you an answer of 0 up to and including 1. Okay, a geometric probability, actually the definition of any probability, is going to be the favorable outcomes divided by the total possible outcomes. So the probability and length would be favorable lengths over total possible length. And then the probability and area of favorable area divided by the total possible area. All right, we'll practice these different probabilities on the next set of problems. Here are some examples. Number 1, you have 4 friends that live on the same block. There are 9 houses equally spaced on this block. What is the probability that your friend lives in a random house picked on this block? So the probability of your friend pick his or her house being picked, that would be the probability. The favorable would be your friend. So we'll just put friend's house divided by the total number of houses. Okay. The number of friends' houses you have on this block is 4, and the number of total houses on this block is 9. So if you divide that out, you have 4 tenths repeating. You have your reticulum, which if you write it as a percent, it would be 44 and 4 tenths repeating percent, or approximately 44%. Now, the value here of your probability is between, the probability of your event is between and including 1 and 0. So you have 4 tenths that falls in between the probability values that are acceptable. Example number 2. The block is 240 yards long. After it snows, each house is responsible for shoveling their sidewalk. Your friends are responsible for shoveling before they go to school. If you are the only if they are the only ones that shovel by 7:30 a.m., what is the probability that if you walk on that block at 7:30 a.m. that the sidewalk will be shoveled? So let's just write this as the probability of shoveled. That would be comparing your shoveled length, that's your favorable length, over your total length. So, little sidebar here. You have 240 yards. I'm going to convert that into feet. To do that, I'm going to multiply yards using unit analysis. I have yards on the denominator. I want them to cancel. 1 yard is equivalent to 3 feet. So my units of my yards will cancel, and I'm actually going to be multiplying 240 times 3, which will give me 720. Now my units are feet. Feet survived, yards canceled. Now that represents the total number of feet on my block, and I have 9 people that live on the block, and they're equally spaced. So each person is in charge of 80 feet of shoveling. So I'm going to do this up on my proportion, or my probability. The shoveled length is going to be, I have 4 friends, and each of them has a front amount to shovel of 80 feet. The total length that is going to be shoveled is going to be 720 feet. So I have 320 over 720, divide them both by 10, divide them both by 8, and we end up with 4 over 9. Again, is 0.4 repeating. So that value falls between 0 and 1. Okay, let's go to the example number 3. A monorail runs every 12 minutes. The ride from the station near your home to the station near your work takes 9 minutes. One morning, you arrive at the station near your home at 8:46. You want to get to the station near your work by 8:58. What is the probability you will get there by 8:58? Okay, let's go with this notation of probability workstation. We want to be at our workstation on time. Okay, so we have a favorable waiting time. To the total waiting time. Alright, I have, since the ride takes me 9 minutes, from 8:58 to 8:46, there's 12 minutes there. But my ride takes me 9 minutes, so I only have up to 3 minutes that I can wait and get to my workstation, the station by my work, on time. Now the number of minutes total that I have before the time I want to be at my station is 12 minutes. So if I reduce this, I have a 1 over 4, which is 25 hundredths, or you could say 25% chance of doing this. Any form is acceptable. Alright, I'm going to stop this set and pick up with some geometric probabilities in the second set. So you can look at those in just a bit.